All right, I guess it's 2:20. I can start. Okay, so my name's Walt Miner. I work for the Linux Foundation. Basically, I've been with the Linux Foundation about 5 years. I work on a project called Automotive Grade Linux. I don't know if people familiar with Automotive Grade Linux? Hopefully. I'll give a quick couple-minute rundown on Automotive Grade Linux. Previously, I was at Monte Vista and Mentor Graphics. I used to work for Continental, a tier 1 automotive supplier. I did mobile devices, I did Linux there. I was tier 1 automotive supplier with Motorola. And then just to throw in the safety critical part, I used to work for ITT Avionics and Northrop Grumman doing electronic warfare systems. So I did radar jammers back in the day. So I've got some experience with automotive and with functional safety type stuff. So what is AGL? So I basically have two goals here today. One is to keep you guys awake after the first, the initial post-lunch lull. Hope we do that. And then the other is to kind of describe to you where we are at AGL with functional safety, with hypervisors, and how I think we can work together, the AGL community and the Zen community, to try to get something done on a real project in the next couple of years. So that's kind of my goal here. AGL is collaborating to build the car of the future through rapid innovation. So basically we're an open source project like you guys, hosted at the Linux Foundation, and we have something called the AGL Unified Codebase, which is our distribution that we work on. The idea for AGL is our tagline is, or our mission statement kind of in the background is, if there's Linux running in the car, we want it running AGL. We think it should be running AGL. Automotive Grade Linux should provide a common software platform for any car manufacturer, any tier 1 supplier to build on top of AGL, build their applications on top of AGL in the infotainment space, for an instrument cluster, for a head-up display, telematics and connectivity, advanced driver systems, and eventually autonomous driving as we move forward. Our unified code base, which you may be familiar with if you know of AGL, basically we're developing a single code base. Everybody working on AGL is working on this code base, and we're trying to develop about a 70% of the platform so that somebody could come pick up AGL and have the starting point and get to production fairly quickly. A lot of these IVI systems and these instrument cluster systems that you see in your car, they're taking 3 to 4 years to be delivered, and there's a lot of old school thinking and what goes into there. For example, the locking down a platform 2 or 3 years in advance, things like that. And we're really looking to disrupt the whole software model of automotive and really more emulate the mobile device space in terms of being able to rapidly bring new features, new applications to the driver. So we're not only are we providing this code base, but we're trying to cultivate an ecosystem of developers and educate the suppliers and the tier 1s in the automotive space what open source is about, what rapid innovation and rapid software development really means, and providing not just the software, but some reference hardware and applications that people can then take and start playing with and putting into their vehicle, or playing with at home and maybe trying to emulate what's going on in their vehicle. We have 9 different car manufacturers now supporting AGL. Volkswagen is our most recent joinee. They joined back in the spring. So we have most of the Japanese ecosystem, Mazda, Toyota, Honda, Suzuki, Subaru, a couple of German manufacturers, Mercedes-Benz and Volkswagen, as well as Hyundai in Korea. And we're constantly expanding the number of OEMs that we have supporting AGL. In addition to that, we have in addition to the 9 OEMs, we have over 130 companies involved with AGL who are members, including those OEMs, tier 1 suppliers like Denso, Panasonic, Continental, Aishin AW, a whole bunch of them. Silicon providers like Qualcomm, Intel, Renesas, NXP, and system integrators, your tier twos like Nuance and Amazon that are providing voice technology, things like that. So a whole range of the ecosystem are really involved with AGL and have been contributing both code and design and architecture to it as we go along. Our UCB, we do 2 releases per year. We name them after fish. This is probably the most important job I have, which is to come up with fish names in alphabetical order. There's a constant search for new fish names. In fact, we had a Linux Foundation all hands meeting just yesterday, and Dan Cauchy, my boss, was presenting an update, and the people on the Slack channel for Linux Foundation were asking if I was accepting suggestions for future fish names. And basically, no. I do all the research myself. So the next release we have is coming out at the end of this month. It's called Happy Halibut. And then later this year, or beginning of next year, Itchy Icefish. We do two major releases a year, and then we probably do 4 to 5 patch releases for each of these as we go as we support them. So how does Zen fit in to this? We have, and I hate the name expert groups, but that's what they call them. We have these expert groups, and they're really groups that are focused on the design, the code of a particular area of AGL. And the number of expert groups has evolved over the years. We started with about 4. We've now got 11 that are active. Most importantly for Zen, there's 2 of them. There's the virtualization expert group, which is looking at virtualization, hypervisors. And most recently, we formed this year an instrument cluster expert group. And if you're familiar with VIA-CARs, well, let me just start with the virtualization expert group. But if you're familiar with what an instrument cluster is, that's the thing that's sitting in front of you, in front of the steering wheel, with all your dials and gauges and important indicators and things like that. The virtualization expert group has been active since 2017. Focus includes primarily hypervisors, but also Linux containers. And last year, right about a year ago, published a white paper. The slides will be online. I didn't upload them yet, but I'll upload them right after this presentation. And you can go download that white paper. And I have a list at the end of the presentation of all the people who contributed both to the white paper and to some of the other slides that I have here. But there was quite a few contributors throughout the industry in creating this white paper that defined the software-defined connected car architecture for AGL. And really, a couple of different ideas came out of that. First one is, the major idea is that there's about 300, you hear numbers from 100 to 300 different computers or chips or electronic control units in your car. So that's everything from your anti-lock brakes to your engine controller to your entertainment system. There's the rough estimate, depending on the car, 100 to 300 different processors. So one thing that your OEMs are always looking at is, how do I save money? Because I want to make that car as cheaply as possible. And the idea is that if they can take a few of those boxes, a few of those ECUs, and combine them, then I can save on the hardware bill of materials. So maybe, and through the years I've seen this done different ways, but maybe you can combine the infotainment system with the telematics system and the connectivity. Maybe you can combine the instrument cluster with the infotainment and drive those displays off of the same system. Maybe you can combine the instrument cluster with that head-up display that goes on your windshield. So what the car manufacturers mostly, when they're purchasing departments, what they're mostly interested in is how much does it actually cost to build that car. So if I can combine 2 ECUs that used to cost $500 and I can source that for $300, that's a savings. And usually they're willing to eat the NRE. They can just, if you're selling a million Ford F-150s over its lifespan and you can save $200, well, that's $200 million bucks. There's no way it's going to cost you $200 million to work on that software. That's their kind of high-level thinking. The problem with that high-level thinking is then they realize they've got to carry that cheaper but fully functional ECU throughout their vehicle line. And well, maybe their low-end car doesn't need all of that functionality, and that ends up actually raising the bill of material for that low-end car. And what I've seen over the years in the automotive industry is they centralize their ECUs, a bunch of ECUs, then they realize this conundrum that comes along on their purchasing department or some other vehicle line department, because these car companies are really highly decentralized. And they suddenly say, well, we don't want to pay for this $300 ECU. We only wanted that $100 ECU. So then they, over the course of a decade, they may centralize and decentralize as the different areas of the car companies come and go. So it's nice to be able to reuse some of that software as you move that functionality around. And unfortunately, a lot of times you can't. A lot of the times over the past years, the software has been written on very proprietary operating systems or homebrewed operating systems. So it's really difficult to do that. So one idea is you can use virtual machines. You could use Zen for this ECU consolidation. You can move that functionality around. The second big idea is functional safety. So I don't know about you, but I like it when my car is safe. I like when the airbags work. I like when the brakes work. I like when the engine runs and doesn't conk out on me. I like that kind of stuff. So the automotive industry, you know, they have some very detailed functional safety requirements that they've created. In fact, there's an ISO standard that I'll talk about in a second that details that. And different ECUs have different levels of functional safety requirements. So your instrument cluster, you know, it's very important to have maybe a couple of the lights that always are, the engine light or the brake light that's always there. But your brakes, you want to make sure that if the computer fails or if the system fails, it fails in a way that you don't crash. So as you go through ADAS systems, if you have your lane nudging system, you don't want that to fail in a way that you then overshoot the lane because the system failed in the middle of it and you go driving off the road. And you think about autonomous driving, and you really have to have some very high, rigid safety requirements. So the automotive industry created or worked on this thing called ISO 26262. And it has this really exciting title, Road Vehicles Functional Safety. And in there, they defined 4 levels of automotive safety integrity level, ASIL, A through D. A is the least restrictive, D is the most restrictive. And the general consensus that the community has come to, at least for now, is that Linux and open source systems really should be targeting somewhere around ASIL-B. Typically, that would be an instrument cluster system or a telematics system. So you're not going to drive off the road if it fails. Eventually, we may work our way up to C and D, but for now, we want to target B. So the question is, how do we get there? ISO 26262 really, and I think Artem alluded to this in his presentation yesterday, it really requires certification of the whole system, the whole box, or the whole vehicle. And the reality is Zen or AGL or Linux are really just pieces of that puzzle. And we need to provide, at the end of the day, some level of testing and some level of documentation that ensures the assessors that when the system fails, functional safety is still achieved, or if there's some kind of, that there's no kind of hidden failure mode in there that will cause destruction to the car. And there's a lot of people studying this. I'm going to talk about 3 different groups, but there's a lot of people studying this, but really no one knows for certain how to get there. What I keep coming back to in my own personal thoughts about this, I'm not a functional safety expert. I'm really not an expert in anything. That's why I hate the word expert group. I don't ever want to be an expert in anything. But is there a good problem statement? What are we trying to get to? And what does victory look like? You know, with the 50th anniversary of the moon landing, Apollo 11. I've been reading this very interesting book about how the engineers solved all the problems to get to the moon landing. It's a very fascinating book, and you can ask me about it later. I actually have it in my backpack. I can show it to you. It's a really great book. The great thing about that is they knew what the problem statement was. They wanted to get to the moon by the end of the decade. They knew what victory looked like. It was, Buzz Aldrin and Neil Armstrong on the moon. We don't know what victory looks like. So what I want to propose to the AGL community next week, we have the Automotive Linux Summit in Tokyo. I know Lars and Artem will be there. Lars is giving 2 talks because he's really brave. I'm giving 2 talks too, but we have an instrument cluster expert group. And that instrument cluster expert group is being led by an OEM, by Suzuki, who really wants to get this into their cars and into their motorcycles in the near future, in the next few years. So we need to really get a readout from the OEMs. There's a lot of participation, not just from Suzuki, but from Mazda and Toyota in this instrument cluster group. And there's participation from Denso and Denso 10 and Panasonic and Continental and a lot of the other tier 1s that might build this thing for them. So let's get a readout. What exactly is the safety critical part of the instrument cluster? And the kind of the high level idea that even Suzuki has proposed, and I think they're going to dive into a little deeper next week at Automotive Linux Summit, is, do we move to a mixed criticality model with AGL and a hypervisor? AGL and an RTOS on top of a hypervisor like Zen. And we know that AGL, EPAM among others, they've shown AGL running on top of Zen at CES this year. People have shown AGL. We know that AGL can run on top of Zen. I don't think it's a big issue. Of course, we'd like someone to open source this kind of the stuff that glues it all together, and I think that'll come soon, but we know it can be done. The white paper that I talked about has this diagram in it, and I just wanted to kind of give a 1-slide overview of, it shows we want to run this, we call it the AGL virtualization platform. We want to run non-critical environments, basically, next to critical execution environments, and have some kind of way to communicate between the non-critical and critical environments. Very generic picture. But what I did was then took that and said, okay, well, what we really want to see for this first instrument cluster thing is there's one, instead of multiple NCEEs, non-critical environments, there's one. There's Automotive Grade Linux. And there's a critical execution environment. That's probably an RTOS. I don't know what RTOS. Maybe it's Zephyr. Maybe we'll go all open source. And given that it's Suzuki, I think there's a good chance that, given the cost pressures, it'll be all open source. So AGL as the non-critical environment, some kind of certified RTOS as the critical environment, Zen as the virtualization platform, and they really want to drive down to a Renesas R-Car E3, which is a low-end R-Car chip, if you're familiar with the R-Car family of chips. There's a D3 that's even lower that they've talked about. But when you look at, if you go onto AGL, I have at the end of this presentation, I'm not going to show all the slides, but I have a whole list of developer resources for AGL where you can find our requirements, our Confluence page, our wiki page. And if you go on our wiki and Confluence pages, you'll see some of the requirements that they've outlined for the instrument cluster, and it really looks like it's almost an IVI system. So we really need to kind of scale down those requirements to fit even into an E3 or a D3, which is really tiny. Whoops, what happened? So there's this other organization called ELISA, Enabling Linux in Safety Applications. It's also a Linux Foundation project. It's fairly new. AGL, we've looked at functional safety with OSADL and with other groups for a few years now. Really came to the conclusion that it's not just an automotive problem, but it's a cross-industry problem. It's healthcare, it's infrastructure like energy, industrial. And AGL really, to do all the work that's needed for the big, functional safety questions to get to something like an ASIL-D. We just don't have the funding for it. AGL doesn't. So cross-industry, this ELISA has been formed, but it's just getting started. Their first face-to-face meeting was held in June. They have a website. They have a mailing list. The mailing list has gotten kind of active lately. They have another face-to-face meeting that they're proposing for Cambridge in the UK in September. So I think in talking to Kate Stewart, who's kind of shepherding this project for the Linux Foundation, I think they're 2 to 3 years away from having something conclusive, kind of the big picture nailed down. Where I think the approach that Zen is taking with, let's come up with some requirements to come up with a smaller version of Zen, see if we can certify that and build up from there. And AGL's approach, which is a fairly small system and instrument cluster, I think we can work together to achieve something in the shorter term than where ELISA is going. So basically, how my open question is, how can AGL work with Zen to get there? I'm just throwing out this time frame by the end of 2020, so that we can at least talk about something where we can bring something to an assessor to say, okay, here's AGL running on top of Zen with this other RTOS. How far away are we? And does this make Suzuki or some of the other OEMs happy in terms of their safety assessment? So that was really it for my slides. I only had about 20 minutes, so I have, like I said, in here there's a bunch of getting started documentation on AGL, how to find our binaries and things like that. We use Garrett, we use Git, of course. I have a weekly developer call that I run on Tuesdays. We get about 30, 35 people dialing in lately. I try to keep everything to an hour or less. We're on IRC. We have a mailing list, of course. And then these are all the various acknowledgements. And then there's some sources.
You were asking questions.
Yeah. Ah.
I'll let you start.
Yeah, I just want to add that in Tokyo we'll be showing AGL instrumental cluster on Zen with optional telltales, which is like this engine failure,
Right.
Another, how do you call it, dump lamp or dump, whatever.
An engine light, basically.
Yeah. Basically, there are like 3 or 4, I think, which are critical, including engine failure and some other. I think oil as well.
Oil as well, yeah.
But nevertheless, and those are supplied by optionally on Cortex-R, which is collocated, or in RTOS running as a guest or whatever else.
Mm-hmm.
So that's
That's your demo at ALS.
Yeah. And you mentioned the glue layer. Glue layer is public on our GitHub under, I think, the user space is under Apache 2 license.
Yeah, I think there's isn't there a meta virtualization too that we can pick up?
It's meta virtualization, and on top of it, bunch of other stuff designed for AGL, because meta virtualization is just meta virtualization.
Right.
Yeah.
So, by the way, one of the things that we do have is, and Artem probably knows this already, we have a fairly robust CI system, Jenkins with Lava, that's fully integrated into our Garrett, so no patches get accepted unless it gets built and it runs through our automated testing. So we already have some of that infrastructure built up as well.
That could be interesting and an interesting discussion. I guess one of the other ones, and when we started the SIG, it became very clearly apparent that pretty much nothing can move forward unless you get assessors involved straight from the beginning, because otherwise you're going to try and do something and then try to get it at the through a process at the end of it, and you don't know when it's going to fail or not. So one of the things which was actually interesting at we kicked off with a 2-day workshop in Cambridge in March, and then we set up, and we actually had quite a few assessors kind of engaged and are still engaged. So that we have, I think, 4 right now, and then there's another 2 in the pipeline. But the big issue is kind of how you do fund that, because none of them really do stuff for free, right? Also, we have some which promise that they might do some stuff for free. It's
there's no such thing as a free lunch.
There's no such thing as a free lunch, right?
So one of the discussions we're having at the advisory board meeting for AGL next week in Tokyo is, I didn't really talk about it here, but there's also been a request for how do we get to production for AGL? And is there, we're doing a release every 6 months. At some point, do we do a long-term support version of AGL? And going, mixed into that is funding. How do you fund those things? But also part of the discussion is you want functional safety. There's a long-term maintenance aspect to that. Yeah. And there's also, how are we going to fund that, and how are we going to fund the assessment, and what assessment do we actually want to do? So we're going to be discussing that at the advisory board level next week. I don't expect any announcements to come out of it yet, but it's definitely a topic of discussion. And AGL does have we do fund development, so. I have, I think, 6 different contractors, that I fund right now.
So I was kind of talking a little bit. Does anyone else have any questions?
So I'm not quite as familiar with 26262 as some other ones that I've dealt with in vehicle safety.
Right.
But one of the major concerns you have when you're doing any sort of certification is the reams and reams of documentation about how you built this.
Yep.
And you can frequently back create that and sort of tell the story of what you were thinking when you did development, or even better, sometimes a story that you hoped you were thinking when you did the development.
Right.
But creating all this documentation and tracking when a change in the code changes the documentation and all that sort of stuff is a giant pain. And so have you started, is that what ELISA's working on? And
yes.
Okay.
So if you go look at so they did, like I said, they had a face-to-face meeting. The minutes are now on their website. The minutes, if you send me an email, I can point you to the minutes. I think they're on a wiki or in their mailing list. I don't remember exactly. But part of that is, how do we tell the story of Linux? We have 27 years of development history. So how do you tell the story of what we were thinking?
Yeah, I know there's some folks working around a whole bunch of problems. Like everyone has this problem in every industry, right?
That's why, and that's,
So there's some work coming out of NIST especially with crypto, trying to figure out the story of how do we run crypto safely on Linux when we don't know where it came from and all that sort of stuff. There's some interesting work on there that we can all sort of maybe circle around, but if you can crack any part of this nut, that will help us all.
And we attended this first face-to-face meeting. The release manager for AGL, Jan Simon Muller, he attended this. Most likely will attend the second one in Cambridge. And we've been keeping up with what OSADL's been doing, and a lot of the problem is funding.
Yeah.
Even if I had, like I said, there's a lot of, even you just kind of said the same thing. There's a lot of people studying this, but no one knows for certain how to do it. And a lot of the uncertainty is around who's going to actually jump in and fund the people that it's going to go take to make sure that this gets done.
So the only suggestion is I might point you specifically to the people doing FIPS certification on Linux, because they're, especially with a lot of cloud computing and wanting to do safe crypto in the cloud, there's a lot of people looking at that right now, and they might be slightly ahead.
Okay.
So they might have some resources there for you. Now, I mean...
Not for me. The resources that are doing something that might help us.
Yes, exactly. Yeah. I don't want to set your expectations too high, but they're sort of, I think they're slightly ahead, maybe.
ELISA has done a good job of setting expectations pretty high. So let's see. I mean, they're off to I'd say a slow start.
I mean, it was actually interesting, this whole tools and traceability and documentation thing. This came up very early in that workshop and in a SIG as well. And then, you know, if you actually look at all the traditional tools, all proprietary and commercial which are available, none of them fit into an open source workflow. But there are a few tools there's like something called doorstop, which, you know, which might help. And I kind of looked at it, and at least it fits into the workflow, because you can, you know, you don't have to build up an entirely parallel universe of things, but then you still have to figure out how you map all this, you know, like map all this stuff kind of together. And actually, we're having a design session of just like where we're trying to come up with something for Xen, you know, assuming that we will get the resources to, you know, retrofit all those documentation. We would actually, before that, we would need to know how we manage this, right? And where the stuff is and what kind of other tools we're using and things like that. So I guess everybody is kind of coming very quickly against those sort of same barriers, right?
Yeah.
I just wanted to add that ELISA was based in part similar to what Intel is doing with the Clear Safe Linux, which is another project, not under Linux Foundation umbrella. So ELISA was based in part on a project that was like around 5 or 6 years already, called SIL to Linux MP, which was driven by OSADL, and they decided at some point to take a completely different approach.
I got to give up.
Oh, yeah, sorry.
Yep, my time is up, so.